All right. Welcome to Unit 4 Notes. So we're going to go over the topic 1 notes today. All right, this is the first set of notes that we have. So, systems of linear equations and inequalities. We have this important information. We have our vocabulary right here. And let's jump into it. So let me kind of talk about what a system of an equation is. So we're used to seeing just an equation like this. Here's a random example plus 3. All right, cool. Here's an equation. Now, we're used to seeing stuff like this. Now, when you have more than one equation, like when you have y equals 2x plus 5, right? This right here is called a system. It's just more than one. It's called a system of equations. Now, if you can even add another one, right? I can say y equals negative 2x minus 3. Now, this is still a system because we have more than one. So when I talk about system of equations, I'm just talking about more than one equation. All right, let's go on to topic 1 notes. Topic 1 meaning the first set of notes that we have. Okay, so solving systems of linear equations and are by graphing. So what do we need to do today? We need to talk about how to find solutions. How to find solutions, right? These things right here. All right, how to find solutions. Here we go. We have 3 types of solutions. One of my solutions is one solution, right? So we either have one solution. We've actually talked about something similar like this. Now, in this case, when we have one solution, our solution is where the lines intersect, right? This right here. So this point right here is a solution. I'm just going to make up an equation for this line. I'm going to say this is y equals, let's say equals 3x plus 5. And let's say this equation right here is y equals negative 2x minus 1. I'm just making up lines. All right. So a solution for this equation and this equation is right here. It's basically whatever point this is a solution. And our solution looks like this. It looks like a point, x comma y. Okay. Now, what I also want to say is that how do we know when we're going to have one solution just based off of equations? We know we're going to have one solution when equations look, so we will put just different equations. Different equations. Meaning completely different, like completely different slope and completely different y. Completely different slope, completely different y-intercept. That's when we have one solution. All right, now what is this middle one? This right here is considered no solution. All right, we have no solution. Now, how do we know when we have no solution? When the lines are parallel. Okay, now how do we know when we have parallel lines? When the slopes are the same, so same slope. I'm going to show you an example in a minute of how all these look. Okay, if I'm looking at 2 equations and they have the same slope, then they have no solution. Now, this right here is called infinite solutions. Infinite solutions. All right, now how do we know when we have infinite solutions? When the equations, so we'll put same exact equations. Same exact equations. When you have the same intercept and the same slope, right, that's when we're going to have infinite solutions. So let's go and look at an example real quick before we jump into the notes. Go here. Bam. All right, let me refresh this. Okay, looking at this real quick, what I want you to notice is here are my 2 lines intersecting, right? Now, their solution is that point right there, A. That's their solution. Now, what I want you to notice is the equation 1 and equation 2 over here, they're 2 completely different equations, right? They're 2 completely different equations. Equation 1 is y equals negative 3x minus 4. Equation 2 is y equals negative x plus 2. Now, that's exactly what I'm talking about. When they're 2 completely different equations, we're always going to have at least one point where they intersect. And the solution for this one is negative 3, 5, right here in this green answer right there. All right, so that was one solution. Let me show you what parallel lines look like. So here's 3x. Oh, negative 3x. Here's negative 3x. So that's what 2 parallel lines look like. Now, when they're parallel lines, they have no solution because they have the same slope. Now, let me show you what infinitely many solutions look like. They have the same exact equation, so I need to have them matching equations. Bam. So here are two equations with this that are the exact same. So they're right on top of each other, which means they have infinitely many solutions. So our graph will either look like this, it will look parallel, or it will intersect. It just depends on which way what we're looking at. So let's go ahead and try to knock these examples out real quick. This right here, actually, I forgot this middle part. All equations should be in slope intercept form. Slope intercept form. Slope intercept form is y equals mx plus b. All right, so let's go and do this. Step one, let's check y equals mx plus b. Are these in y equals mx plus b already? Check, so we're good. Yep, good. Step one. All right, step two would be to graph. Now, how do we graph? You always plot the y-intercept first, plot y-intercept, then use slope to make more points. All right, we have that. Use slope to make more points. And then we can figure out what is its solution. Let's go ahead and do that. So I will use two different colors. Let's call this my blue line. Let's call this my purple line. All right, blue. In order for me to plot this blue line, my y-intercept is a -8, right? Here's a -8. Where's my y-intercept? -8. So let's go down. We have 1, 2, 3, 4, 5, 6, 7, 8. Y-intercept, bam. I need to use my slope to make more points. What is my slope right here? Well, my slope right now is 1. So my rise over 1, anytime we have a whole number, we put it over 1. So my rise over 1 is 1 over 1, which means we go up 1 over 1, up 1 over 1. Now, I'm going to recommend that you guys make as many points as possible because we need to figure out, when I make the second line, where these points overlap. All right, so there's that. That's done. Purple line is going now. So y equals -2x plus 1. Let me go ahead and I'm going to plot that. Y-intercept is +1, and that goes right there. Bam. Now I need to use my slope to make more points. -2 over 1 means down 2 to the right 1. Down 2 to the right 1. Bam. Look, this point right here that I just overlapped, I'll circle it in a minute. This point right here, I overlapped. So this is the solution. So let me actually draw my line now. I didn't want to draw my line yet because I wanted you guys to see where these points would overlap, meaning bam, bam. Okay, now my solution is right here, whatever this point is. And my solution is a point, x comma y. So we're going to say it's one solution, right? Because they crossed, so it's one solution. And now your point is x comma y. What is that x? Let's see, 1, 2, 3, 1, 2, 3, 4, 5. So to the right 3, down 5. So that's it. That's basically all you have to do. You need to determine if it's a one solution, no solution, infinite solutions, and then you just need to graph it. And also remember, if it's one solution, you have to figure out what is that point. So let's do this one down here. All right, step one was what? We need to make sure that they are in y equals mx plus b form. Let's see. This is in y equals mx plus b form. This one right here is not. Let's go ahead and change that into y equals mx plus b. Draw my line. I'm going to subtract x here, subtract x here. What do I have left? Let me put this to black. Bam. All right, so I have 2y equals to -x plus 4. All right, what's next? I need to divide by 2 here, divide by 2 here, divide by 2 here. Y is equal to -1/2 x plus 2. All right, I'm done now. Here's one equation. All right, and here is my next equation. Now let's just let's just go and try to figure out if it's one, infinitely many, or no solutions without even graphing it real quick. So this equation is y equals, right here, this equation y equals -1/2 x plus 2. And this equation is y equals -1/2 x plus 2. So these equations are the exact same. Now, what does that mean? Same exact equations are infinitely many solutions. Bam. All right, let's go ahead and write that answer real quick. I'm just going to do this infinity sign, infinite solutions. All right, infinite solutions. Since they're both the same line, we just actually need to just draw my line once and I'm done. Positive 2, y-intercept. Whoa, whoa, whoa. Calm down there. Positive 2. Down 1 over 2. Down 1 over 2. Let's see, as much as I can. Man, dude, what is going on? Here. All right, let's draw my line now. There we go. There we go. There goes your line and you're done. All right, let's do these last two. I need to change this into, first step, y equals mx plus b, right? Slope-intercept form. So I'm going to do this one right here. So we have negative 3x plus y equals to 8. All right, let me draw my line. I need to add 3x here, add 3x here. So now I have y equals 3x plus 8. I'm actually done. I don't have to do anything else. All done. This is going to go down here. Negative x plus y equals a negative 2. All right, I'm going to add x here. I'm going to add x here. So I have y equals x minus 2. All right, let me highlight my equations real quick. Here's one. Here's another one. Are these the same equation? Are they different equations, or do they have the same slope? By the looks of it, they're different equations, so I already know this is going to be, oops, my bad, one solution. Bam. Now, if it's one solution, I got to figure out what is that point. What point is it that is the solution? I need to plot both of these. Positive 8, 1, 2, 3, 4, 5, 6, 7, 8. Here we go. Down 3. Oh, no, this is a positive 3 slope. Notice, real quick, this would mean go up 3 over 1. Up 1, 2, 3 over 1. My point would be somewhere up here, but I can't graph it. And so if we can't do it, let's do the opposite, because we can make points. We know if it's a positive slope, it's still going to be a line that looks like this. So let's work backwards, do opposite. So what that means, go down 3 to the left 1, down 3 to the left, 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 down 3 to the left. All right, there's my line right here. All right, now I've done that one. So x minus 2, what is x minus 2? So there's a negative 2 here. X means up 1 over 1. Now what I want you to see is that if I keep going this way, my line is, I'm doing this line correctly, but I'm not showing where they're going to intersect. I actually need to work backwards. So instead of going up 1 over 1, I'm going down to the left, down to the left, down to the left, down, and oop, there they go. There they overlap right there. Draw my line. And bam, bam. So where is their solution at? Their solution is right here. What point is that? 1, 2, 3, 4, 5. So this is 5. 1, 2, 3, 4, 5, 6, 7, 8. Was that right? 1, 2, 3, 4, 5, 6, 7. My bad. Negative 5. Oops, sorry, it goes here. Negative 5, negative 7. That is the solution. All right. So I think those 3 problems are more than enough practice for you guys to get this one done. Remember, first step, change it to y equals mx plus b. And after you've done that, figure out, are they the same equation? Are they just completely different equations? Or do they have the same slope? To figure out your answer and then graph.